All righty, welcome back. So, very proud to introduce Marco, who's going to be talking now about fusion cooking of data, facts, rules, and processes. Marco has been developing software across a wide range of applications for many years, and for the past 10 plus years, he's the product manager and lead developer of Case Talk, which is a very powerful fact-based data modeling tool. And Marco and Case Talk have been with DMZ pretty much since the beginning. We were talking about when Case Talk first became a partner of DMZ. We were thinking it probably was back in 2013 in Hanover, Germany. So Case Talk has been with us pretty much since the beginning, and very proud to introduce Marco. Marco, welcome.
Thank you very much, Steve, and welcome to all of you at home. In this virtual environment. Fusion cooking, yeah, it kind of, fusion cooking, what you see depicted here is the toasted ravioli from St. Louis, the food city of the US, a couple of years back. And one of the things that they do is just put things together and make that delicious and nice and work great. And this is just one of those examples. And putting things together in IT is something that we all can benefit from. So, hence the title. Like Steve said, I've been around for a while. Still, factor-oriented modeling is still very current, very actual, current as in needed business terms. You hear a lot of that, information modeling, and I'm going to show you a perspective on how to merge all these different areas together into factor-oriented modeling. So let's get started here. There is some history that precedes IT. We all started with manual information, then it moved into the mechanical information, and now we're in the era of electronic information. And if you can pinpoint the data in these slides, I'd applaud you, because it's not there. It's about information and it's communication. And the loss of that reality is that we now are confronted with many silos, many databases, many applications that serve one specific type of information and communication. And with the capability of tech and the growing of the amount of data pools and management decisions is that we need to integrate that back into one way of looking at data and one way of communicating about that data. And that puts us in a few challenges. So what is that data? And like the picture says, you don't want to take the wrong medicine here. Where is our data? We've all been traveling and having the question, where is my suitcase? So, even in a large enterprise, this question comes back to where's the data? What does it mean? Who is accessing the data? Who is using the data? With the GDPR, that is more and more prevalent. And in the light of logistics, when did we get that data? Is that still current? And when are we getting the data? All different aspects, questions from the business side that IT somehow needs to figure out how to answer this. And finally, data affects real lives. We see it in this pandemic, but it's been around for a while. So are we sure? That is a question which puts us to the test. And by now we should all realize that data is not the same thing as communication at all. So I added a slide because I saw some philosophers coming by that DMZ, the dialect of factor-oriented modeling that I'm a fan of is inspired by Wittgenstein, that wrote once, if we cannot speak about it, we should be silent about it. And there's a little joke here because it points, of course, to the importance of language. And this man tried to put rules down on how we should use language in an unambiguous way. And in this specific line was actually pointing to the context of religion, because, how can you talk about God if there's no language about it? So he was not a big fan of that, and but he realized his mistake when he was out in the street and given the middle finger that involved no language at all. So what happens with language? We've all known the kids game, Chinese whispers, or the telephone game, or whatever name you gave it to it, and there is this disconnected concerns in the business and in IT that propels itself, and as it moves forward, there's a loss in translation aspect. You can find it with business and IT, the other way around, or in business or in IT. Things just don't always mean the same thing anymore. So now we have this business need, and the business finds itself in a position where, how do you specify requirements? How do you tell IT, who's not trained for the business side on the job, how do you tell them what you do? As a brain surgeon, heart surgeon, or just anything that involves training, 10, 20, 30 years of experience, how do you communicate that to someone who does not have that? And the way to do that is to find a way to capture that human communication. If I would be on the phone call with my colleague, I would actually use the language to explain what's going on at work. And that is not a very scalable way of communicating information. So that's where IT systems come in. It's a scalable way of writing down what's happening at work, and that's being communicated throughout the organization to colleagues, departments, managers, etc. So, but we need to figure out how to formalize that language in a way. And if we can do that in a way that allows us to express facts, we can then capture that and propel that forward to system and generation. And in the process of capturing that communication and writing down the information and writing down the language, the nouns, the verbs, the core business concepts, however you want to call them, you create a certain alignment in the way that we talk about the things that we do in business, and that we as IT need to facilitate. And that creates a shared common language where it varies a little. You would have shared domain languages, but there can be domains in the organization that are very specific and do not share that part of the information, and then it becomes a domain-specific language. But there's an overlap. And what we actually try to do with factory-oriented modeling is trying to provide methods and tools in managing that process of capturing the communication, adding the information grammar with our specialists, and generate all the artifacts that we need for IT production, and in that way come up with system implementation that actually aligns with the communication that we started with. So this slide shows in a nutshell what is actually going on. Of course, there's more to it, but let's just go down to the essence of it. We write down facts. Stefan mentioned it earlier. The facts is how we communicate about data. This is the verbiage of the business. And instead of breaking that down in entities and relationships or entities with attributes, we basically look at it as what is the information grammar in these expressions. And with that, we built like Lego blocks or atoms. These structures, these molecules, break down in all kinds of little building blocks. And we can visualize that, of course, in a diagram once we have completed that process. So in the bigger landscape of information modeling and information management and system implementation, we start by capturing the business requirements. And in our case, we as facts in natural language. We built our elementary model. And as I will show you later on in this session, I will show what kind of outputs you can expect from that and how that process goes. And I also promised a little bit about fusion cooking, so I'm going to talk a little bit about that. So first of all, we need to figure out how to integrate all these concerns that are there. So let's start first with a small example case. This picture is from a car owner, obviously, who had some car trouble. Arriving at work, the car smelled a little funny. They opened the hood, and it appeared that over the weekend, the squirrels had used the hood as a stash for the winter. But it's a cute little case. So let's do a simplified use case here. And what we're trying to do here is just write down in natural language what's going on. I mean, John owns this car. Let's call it car 123, and John calls up and opens this support ticket number 99, and this support ticket is for this car 123. And then Lisa is on the phone. She doesn't actually know what to do yet with it, so she escalates this ticket, and then her manager Ronald authorizes this ticket 99. And then it's assigned to Jack, the engineer, and Jack actually provides the support for ticket 99, and the whole case is solved. Everybody can read this. It's natural language, and it perfectly describes in a concrete world what's actually happening. So let's type this out, and let's start from there. You can see on the right here that I have retyped all those expressions in concrete form with examples, and I've also classified them as, wait a minute, if I'm saying driver John owns vehicle 22PZTV, then we're actually talking about the driver vehicle. A little further down, Lisa reports to the supervisor. Ronald is classified as this is the supervision. This is, if we're talking about supervision, we're talking about these kind of verbiage. Let's start with the first expression, and in that we can find the grammar that we have something called driver and then owns vehicle. There is some talk about is a verb a relationship or a foreign key. It has nothing to do with that. It's just part of the communication. But within that same sentence, you can dig down and say, wait a minute, I said something about driver John, and there is this driver, and then there's data. John is a person, and similarly the vehicle, it's the vehicle with a license plate. So we add information grammar to it. The license plate is then illustrated by the example, and person is identified by the person name, in our simplified case being John. Now, basically, this is the process of information modeling. If you use factor-oriented modeling or the product case talk, this is the process that adds the knowledge to the facts and that we can work with. So let's depict that graphically. You can skip the numbers for now. They're basically meant there as substitution pointers. You can read the expressions, you can read the examples back. As an experienced data model, information modeler, or factor-oriented modeling, you would navigate your way through graphs and expression trees and all of that. So I'll not go into the details there, but it shows that we can easily make a composite picture of fact expressions. So let's do another one. Let's add the support request, and I'm going to expand this diagram by saying, okay, this is the information grammar from this fact, and it adds to the diagram that we already have. You can see the support request, and it basically connects the driver to a ticket, and it repurposes the previously entered facts and expressions and structure and all of that. So it actually adds a very smooth experience to the modeler. And we're going down. We're doing ticket vehicle, and again, it's a information grammar that simply adds one new fact type, ticket vehicle, and repurposes the vehicle and ticket. And we go down to the next sentence, the ticket escalation. It will add the employee who actually escalates the ticket, and you see here that these connecting fact types, they have a name, but the verb is actually part of how we communicate about it. It's not necessarily directly related to a name of a foreign key. And again, there is a lot of talk that we can do about it. So I invite you to come and do the Q&A live session later on if you have further questions. Supervision. Yes, that one introduces the supervisor as a subtype of employee. And then we go to the support authorization. Ronald authorizes a ticket. And then we have an authorized ticket, which is a derivable fact type. I'll come back to that later on. And finally, the actual support is done by Jack. And now we can zoom into the diagram a little and see that with just 7 statements, 7 facts, we built a very rich information model that can be read and validated by the business itself, not necessarily from this diagram. So what is it that, for instance, a database would need to be? Let's go one slide further and do a entity relationship diagram. Completely derived from our information model is this little database structure that says these tables are there. We have the primary keys, we have foreign keys, we have columns in there. Added, however, to it is the actual communication again, because we moved that from the information model to the entity relationship diagram. So still presenting this, even not knowing entity relationship diagramming per se, you can still read how that table is being used in business communication. Of course, a different transformation would depict it in a UML class diagram, slightly different than a database structure, hence the need for object relational mapping for software developers. And we can, of course, generate a physical database directly. And here it shows the tables for the ticket, the driver, the employee, and interestingly enough, a couple of database views on top of that, resurfacing the communication from the business. So even application developers can simply query the data and report it back in natural language. And it doesn't stop there. For the Data Vault users that want to see their core business concepts, their links, their satellites, this same information model can be colored slightly differently, and then you see those core business concepts appear and the required links between the hubs. And interestingly enough, it's a very simple model, so it doesn't have any satellites added to it, but they will be depicted in yellow. So how does that work? How to train your model? Once you have this information model, we need to actually compress it a little and reorganize the structures a little. So let's look at a simple example on how that works. We have here a very simple set of statements. The patient 123499 has family name Smith, and the same patient is born in Utrecht. A very rich information model is depicted here, but we're going to transform that. First of all, and you can read back the slides or the video later on. So I'm going to go ahead in full speed, and you see the example population under, if you look on the left, patient surname, it has Smith and patient number. And then underneath the patient, you can see the patient number. And underneath the city of birth, you can see the patient number and the city. So what you're actually trying to compress here is if I can pull roll 4 and roll 20 into the patient, I will end up with a slightly different structure. And the interesting part in is that it maintains the communication. It is not lost. It is simply the structure that is being compressed. Another part is if you want to build databases, you need to know every data type for every column. So roll 21, which is a reference to the city, needs to be finished off with, wait a minute, that needs to be the actual city name in the end. So I'm cutting that line and I'm moving a new line in and says, wait a minute, that needs to be city name. And then once we moved and collected all the communication in underneath the patient entity, you will then see that city itself does not bear any relevant communication anymore. So we can reduce that, and now we're at a point that you could see a database table structure. And from there, we can move forward. We can generate our DDL, our DML, because we already had the examples. Software developers and testers love this stuff because they don't have to make up an example population. It was given to them by the information model, by the business. And also interesting is, okay, then we can automate the creation of database views that actually represent that communication again. So generating an ERD, document it, not a separate document that describes how to communicate or how to use it. And naturally, that is not the end of the story, because we have semantic web. Also, sessions in DMZ, we're talking about that. We have high-level concept maps. That is great to have this high-level talking picture. The software developers need to have this UML class diagram. But hierarchy is also mentioned. We can output the JSON structure for the web API developers that still align with the communication and the information structure from the business. We can do XSD for enterprise service buses, you name it. And as Wouter and Roy presented yesterday, there is the possibility of having your data model generated inside of Power Designer and ER Studio. Again, all documented in a way that upholds the business communication. Now, that's just the data side of things, if you will, because there's, of course, more to it. One of the things that I wanted to address here is the Fusion part of it. And first of all, I'm going to talk a little bit about how do you pull data out of it? What are the rules and on derived information for it? And you can see here a small information model. It says something about person, parent, child, birth date, salary, gender. A little tricky topic at this moment because gender is very fluent nowadays. So bear with me. I'm going to start with this expression that had the grammar as depicted on the left. Mary is the parent of Joe. Now, if you look at the information grammar, it already naturally joins parent, child, person, name, and it provides valid examples. So how can we use this information and to derive in it? Let's go one slide further. A simple example says, we have an expression, Joe is a baby boomer. And we can state those as a fact, and we can enter those in an information model, but we still have to figure out how does that relate to the fact that said Joe is born on 1/1/1960. So for that, if we look at the fact expression, you can see the information grammar, Joe is born on 1/1/1960. And all we have to do is to make that link between Joe is a baby boomer and the fact of when he was born is to add a where clause that says the date of birth needs to be between 46 and 64. That's a simple where clause. I'm going to do one further, and I'm going to say for a different set of expressions, Abraham is the grandparent of Joe. And for that, I use two previous fact expressions. I'm saying Abraham is the parent of Mary, and Mary is the parent of Joe. So if I join those two expressions together on the Mary part, which is the child 04 in one expression, and it matches with the parent 03 in the other expression, I actually have the join that I need to have to populate Abraham is the grandparent of Joe. So let's move those forward and put those two together. Let's see what we can do here. I have another fact that says Mary is a mother, sorry. For that, I need to have two statements. John's parent is Mary, and Mary is female in this case. If I join those on the parent person function, and I add the where clause that says the gender is female, I end up with the population for Mary is a mother. So it joins different facts and it adds a where clause. All good and well, but we have more to come here. Let's take another example. We have a fact statement that says 300 euros, and I know that the exchange rate is horrifying. The 300 euro is the highest male salary as a fact. But how do we get that from our information model? How do we, in the end, query that from our database? Is simply by specifying and using Abraham or 300 months or euro a month, and Abraham is male. And again, I'm joining them on parts of the information grammar, and I'm adding the where clause that the gender is male. And then over the result, I add the function that says give me the maximum amount. And then we would have populated the 300 euros is the highest male salary. So there is the need for functions. This doesn't require an entirely new piece of rocket science. It's basically something that you probably already recognize from Excel spreadsheets. We need simple declarative functions, which either return a set or a scalar value, and it accepts a set or a scalar as parameters. And with that, we can build our entire rule set based on what I've shown you earlier. And interesting, those are done to calculate or derive populations. And we can use the similar set of constructs to build database constraints because they're just logical Boolean evaluations. So it needs to be yes or no. So that's the rule part. And let's move on to the process part. The processes basically consist of steps, and these steps involve what I name business transactions. Business transactions actually act on facts or derivable facts, if you will. And the added bonus is once we have that in this, capture that in that way, we have security by design. We have data lifecycle insight. And let me illustrate that. First, we define a business transaction called the citizen registration, which then would, in that process step, we would create three facts. The fact person John Doe exists. John Doe is born on 1/1/1980, and John Doe lives in New York. And you see that in the matrix underneath, which then boils down to a set of CRUD transactions. So the business transaction is not necessarily the same as a database transaction. It really focuses on the process side, on the business side of our data, of our facts. And I'm going to show you another example, and I'm going to show that in a similar fashion, which is the actual moving from one city to another. To be able to apply that, I need to read the fact that says John Doe exists, because otherwise there is no precondition. What am I going to change? I need to have a key fact to operate on. And I'm going to update John Doe lives in New York. So in the matrix, you will see I'm reading the person and I'm updating city of residence. The birth date is not involved. So if you go through that systematically, you will end up with a matrix that gives you data lifecycle checks. So in our small example, we see that the birth date is never read in our small little application with two business transactions. And no data is ever deleted and never exported either. And this gives a little clue to where we can design and build permissions audits, and security. Because if we look at the business transactions, we can actually specify, wait a minute, who can actually execute these business transactions? And on a more detailed level, we can add permissions on elementary fact types about the CRUD permissions. And on those two, we can do audit logs. Now that's for just basic CRUD, but instead of listing export as one of the operations, we can extend that to searching, exporting, printing, copying, whatever, and we have a prototype or a template for how to design security within our information model and manage it and deploy it. That way, if somebody would actually export or print 10 million records, a manager could be automatically signaled as, hey, wait a minute, this person has permissions to do that, but he's exceeding a certain threshold. You might want to look at it. So to conclude my fast-paced talk here, we have seen a little bit about how facts can close the business IT gap. It allows the business to, in their own language, express what their facts are, what is their administrative reality, and give examples with that to illustrate that we're still talking about this specific fact, to prevent the confusion about customer or party or person. Once you actually specify an example with it, you drill down to the concreteness of it, and everybody will understand the type level qualifications. We will have high quality information models, and that is because of these elementary building blocks. There's a lot of automated testing that can be done if the structure is actually correct, and it prevents 8 out of 10 beginners' mistakes in data modeling. And by being so precise and unambiguously defined, it's great for business domains that are complex. As I mentioned before, I'm a trained software developer, information modeler, all of that, but I would not comprehend the world of a surgeon. Or if it comes down to analytics on flight tickets, I have no idea. So this actually helps me get to grips with the complex domain of the business. And because it's so detailed, it actually gives, it's really excellent for large domains that have many data types. The Dutch railways there is a good example of that. They have multiple information models that repurpose previously defined information models, fully version management, and they're able to integrate every aspect of the rail infrastructure, accomplishing response times of less than 30 seconds if there's an incident on the track anywhere in the Netherlands. So, that really requires a level of integration of information that can only be accomplished if everybody is on the same page, like Stefan pointed out in our previous session. And we have detailed governance. We can specify where is the data stored, who is the interviewer, who signed it off, and where is it getting implemented. And all the artifacts coming out of it are aligned with this central definition of information. And it provides a very natural path to rules and constraints and process and security. So to open up for questions, and I imagine there is a lot of information to be processed here because I'm going this very fast-paced. I would like to invite you for questions or connect with me in the Q&A session afterwards at the booth. So I'm curious to see how the response of this audience is.
Yes, thank you, Marco. So remember too, Marco has a poll that we could answer about getting the messages. What are the messages out of the session? Marco, can you talk more about how some of your clients may be using fact-based modeling to work with graph. I always found that a really good connection. I always felt that case talk, fact-based modeling is a perfect way for data modelers to transition more to understanding graphs, because you're not making any distinctions between entities and attributes, and it fits really nicely into the way fact-based modeling works.
Interesting question. I've been a long doubtful fan of graphs. I saw that it would add value to it, and I just didn't quite know how to connect that with information modeling. Because from my experience, what I saw for a long time is they're pulling in data and then they're making the connections, which is fed from production systems. And so I had a very hard time figuring out what the added value of information modeling is to graph processing, where you're kind of going discovery-wise, connecting data and slowly giving it meaning. And since the product case talk can already generate the JSON files or export the data in table format, loading that up in a graph environment is no problem.
Got it.
But if you're interested in why would it add value, that is something of an insight that came to me later on, is where I realized, and this is same for data warehousing and ETL processes, etc., is that somehow we deal with source systems and we need to figure out how to get some sort of knowledge out of that data that we have. And we need to figure out how the business actually communicates, because what is meaning to them, and that may not be the same as our source system that we're trying to leverage. So having a business-focused information model, like we're doing with fact-oriented modeling, can actually be the insulator, so you will, between source and target system. So instead of moving, like ETL does on a physical level, move data from A to B and then build management reports on it, and then figuring out how the ETL should work according to the business to give meaning to the report, we should actually map that to a business information model and do our reporting from there. That way, if the source system changes, we only have to align it with the business model, which is not tables, entities, and relationships. No, this is core business concepts. This is terms according to the business. And in a similar way, I now realized, and that's then back to your answer, these information models can then be imported in a graph environment as the insulator. All the other source systems should match or connect to this graph model coming out of a business-oriented information model. So if there is an added value, but it serves no purpose of having an information model in a graph environment and then still having to figure out how the data maps to it.
How the maps, yeah, that makes sense. That makes sense. Thank you, Marco. A couple questions too came in here. Let's see. Question from Stefan. So your models look quite technical. Do you have experience presenting them to non-technical people as well?
Yes. Yeah, that's good point. The diagrams that I showed all the details involved. And with the tooling, you can strip all the details so that it comes down to the bare communication. So depending on the audience, whether you're communicating, like I showed before, but I'll repeat that. If I'm communicating with software developers, they want to talk about UML. They don't care about the information model, the information grammar. If I'm talking back to the business, I would probably group it in some way and have actual fact statements so that they can read it and sign it off. Yes, these facts are correct. And I can illustrate that with a high-level concept map, which is also derived from the information model. So there's a ton of different representation methods that come straight out of the box with this tool. So it really depends.
I like going straight from the business. For me, starting off with the business assertions is such a powerful tool. That's really like the examples you give. I mean, it's instead of us jumping right to these more theoretical, like you can't touch them kind of concepts, you're focusing on the data. I think that's offers a lot of value.
And if I may, and we still have some time for more questions, is that it's also helpful for the business themselves. I've experienced it in my very personal bubble. Is when my girlfriend Jody came from the US. I'm capable of communicating in English, and I'm perfectly fluent in Dutch. And then she asked, when do you use this word in Dutch? And when do you use this word in Dutch? And I'm like, I have no problem handling those variations in Dutch, but I am unable to explain to a novice who doesn't know this world how that works. So, and the same thing happens with whether you're doing a privacy registration application for lawyers, or building pension plan systems for whatever. It's as soon as you are an experienced expert, 10, 20 years, you don't think about your business anymore. We in IT suffer from the same problem. This is very human. And how do you explain what you do? So being challenged on the concrete level about what do you write down to do your work, and what do you write down to communicate with your colleagues? That's the administrative reality that you need to be able to verbalize. And the only way to challenge that process and getting requirements clear and into the daylight is to be able to communicate and talk about it. And I've been in sessions where, after 2 hours, domain experts said, I had no idea my work was so complicated. And that, if you don't engage in that way, you would probably be satisfied with writing down cookie, or customer, or patient, or you don't dig deeper, because they can sometimes only express 20% of what they know. And we as information analysts think we kind of heard 80% already. And there's a huge gap. So the only way to dig down is use concrete examples, get down to the facts. And the fact-oriented modeling approach is not just a way of drawing it. It actually has almost like a procedural way of working through it, which guarantees these high-quality information models. It's really a structured way of approaching these challenges. So,
excellent. Do you have also? You may have it on your bookshelf. I was looking behind you for the fact-oriented modeling book, the FCOIM book. That
I do. I have it right here. Here it is.
Yay. That's a book that we published, and it really goes more into detail. Fact-oriented modeling, FCOIM. Thank you. And another question here too. So we have a few questions. Oh, awesome. Okay, so do you have some references, examples of how different data models, for instance, product, could be harmonized by using this approach? For example, different parts of the organization can define a product quite differently. It's interesting. Yes. It kind of ties back to Stefan's discussion too, where you can have one maybe conceptual high-level model, and then underneath that, all the details.
I've been doing this for 20 years, so I've got some experience in the field. But one of the slides is that I have in different presentations is like you can have customer from 4 different angles. We have the help desk that does support tickets, and we have the website that supports identifies customers by email. So there's different identification structures for the concept of customer. So the different definitions for customer vary as well, because they all talk differently about what is in their eyes a customer. So there is a way to specify, wait a minute, we have the help desk customer, we have the sales customer, you can do that. But the fact-oriented modeling approach doesn't care much about that initially. It just writes down the facts. And then you will see that all things come together in a generalization called customer, but it beholds different way of identifying them. And this is, for instance, a very small example that happens in the rail as well. I mean, we have track, but are we talking about the iron bars on the floor? Are we talking about the whole track from city to city? Are we talking about the track where it has the functional train transporting people? So track can have various definitions, and we can do the physical track, the planning track, the whole track. We can do all that, and we can also communicate all those different ways as track, and which also emphasizes that the communication varies, but the structure is varying as well. Mm-hmm. And lining those two out, you can only do that with language. So different angles there.
Makes sense.
Really, none of it is a problem. We can capture it all. So that's the bottom line of it.
Excellent. We have time for one more question. So from Stephen Beckman. So I understand this translation from fact statements to fact models to be still done manually. Have you experimented with natural language processing, NLP, to generate these explicit fact and information models? It's really interesting because I've been playing with chatbots to do something on the information engineering side. It's interesting.
I've been keeping an eye on this stuff for a while now, and with the tax authorities in the Netherlands, they're doing massive work on this because they have, according to the GDPR, you have to be able to knock on their door and say, I'm Marco. What data do you have on me? Where is it? How is it used? And who looks at it? Mm-hmm. Mm-hmm. They, at this point, they have no idea. I mean, they have over 2 terabytes of MS Access files that are just copied data in the organization. They have no idea where your data is or who looks at it. Huge challenge. Another challenge is they have to align it and qualify the use of that data by law. So they have to be able to pinpoint at a piece of data and say, okay, this law article says that I have to register this. Now, the laws change over time, data, all of those challenges. So what they're trying to do is annotate the law. They annotate it by using different mechanics and natural language processing. But it still doesn't clarify. I mean, the law is specifically written in an ambiguous way to make consensus. Some parts are very accurate because they calculate income tax. Some parts are very nebulous and you need judges to interpret law. So natural language processing is helpful, but that's not the end of it. If you do that for chatbots to come up with an automated answer, great. But would you fly a plane with that? I don't think so. So using that as a tool is great. But you have to go through the steps of business and domain experts to actually qualify and transform that into a solid information model.
That's true. It could be a good starting point. Yeah, it could be
absolutely.
A good starting point. I actually, at our Data Modeling Zone Australia conference a couple years ago, we had a speaker who was using several algorithms, including the bag of words algorithm. So if you're looking at a requirements document and you have the word customer and the word account, and they appear in the same sentence together often, maybe there are 2 entities that are related. So those sorts of things. It's going that way. Hopefully it won't go all that way because then we won't have jobs anymore.
Well, the trick is the maybe. It might be related, and it boils down to what do AI, what does AI do? It looks at statistics and historical data. And it makes interpretations, but I can show a white noise picture to an AI system and it will say, yeah, that is a cat. It's, again, I would not fly a plane with it.
No, luckily, not yet. Hopefully never. All righty. Well, we are right on time. Any other questions for Marco?
Well, I'm still in the booth, so if you have more and want to discuss some, be welcome.
Thank you, Marco. Thanks for the great talk. Thanks, everybody.
All right, thanks. Just a few small announcements before we break. So at 1:30, we actually have a keynote presentation and basically a discussion around boosting your energy from a well-known ex-tennis player, Dominique Monami. If you're Belgian, then you will certainly remember the successes that Dominique had many years ago in tennis. So she'll be talking to the group on the subject of boosting your energy. So that's at 1:30. And then after that, at 2:30, we have the Meet the Partners session. So again, just like yesterday, there's going to be an opportunity for you to go to the various partners that are sponsoring this conference and see in different sessions what they have on offer. And there are also the virtual booths, of course, of the partners that you can go to as well and hook up with the various partners over there. And then at 3 o'clock, we start again with the two tracks as we did this morning. So that's kind of high level the program of what is coming up. So just wanted to briefly mention that. And so thanks again, Marco and Steve, and see you later today.